Bismillahirrahmanirrahim. Welcome to the second part of this topic, which is the inequalities. In the first part, we spoke about the inequalities and we gave some different examples of linear inequalities. And we wrote the solution for the inequality using different forms, either by set builder notation or graph the solution or using the interval notation. In this part, we are going to speak about the compound inequalities. So a compound inequality formed by two inequalities. So we have two inequalities with the connective word using and or. The inequalities, for example, given down are compound inequalities. For example, this is one inequality, which is x plus 1 greater than 3. And we have this connective word and this is the second inequality. We combine two inequalities using this word and or we call it compound inequality. So compound inequality is formed by joining two inequalities with the connective word and or. If we have and, this one, the solution for compound inequality, we are going to use intersection. It means we are looking for the common solution for of the first inequality and the second inequality. We are looking for something common, that values for x that satisfy the first inequality and the second inequality. So we are looking for the intersection between the solution set of the first one and the second one. If we have or, again, this is another compound inequality. I have x plus 3 greater than 5 and x minus 1 less than 9. And these are connected by the word or. For the or, we are using union. So if we have and, we are looking for the common. If it is or, then we are combining the solution set of the first one and the second one, combining all of them, not finding the common one. For example, suppose that we are given this compound inequality. I have 2x plus 5 minus 16 and 2x plus 5 less than 9. So I have two inequalities. I'm going to solve each one separately. Then I will look for the common solution. For the first one, I have 2x plus 5 greater than minus 16. This is the second. So this is the first one. And the second inequality is 2x plus 5 less than 9. So I'm going to solve each one separately. For the first inequality, I have 2x plus 5 greater than minus 16. So I'm going to add this minus 5 to both sides. Then I will have 2x greater than minus 16 minus 5. So 2x greater than minus 21 divided by 2, the coefficient of x. I will have x greater than, since we divided by positive number, no need to change the sign of the inequality, minus 21 over 2. Now the graph for this one, the solution for this inequality. This is minus 21 over 2, and it's open interval. Greater than means go to the right. So this is the solution of the first inequality. X is greater than minus 21 over 2. For the second inequality, let's solve it and see. I have 2x less than 9 minus 5. So 2x less than 4 divided by 2, the coefficient of x. I will have x will be less than minus 2. Or 2, it is 2, not minus 2. So x is less than 2. We know that 2 is positive, it is in the right side. Let's say if this is 0, this is 2. So 2, open. And less than means go to the left. Now I have two inequalities. The solution set for the first one is x greater than minus 21 to 2, and the second one is x less than 2. So since we have this word and, which means that we are looking for the intersection area. Intersecting area or the intersecting solution, the common solutions. And we can see the common or the intersecting is this part. So we can say the solution set for this compound inequality will be x, where x is between minus 21 over 2 and 2. So I can write it as minus 21 over 2 less than x less than 2. This is using the set builder notation, and this is the graph. The solution is this part only. The common area. Using the interval notation, I can write it as open minus 21 over 2, the open interval. This is using interval notation. Let's have another one. 0 less than or equal to x plus 6 less than or equal to 54. This is compound inequality also. This means I can write it as two inequalities. 0 less than 2x plus 6, and this type of inequalities or this form it is a compound inequality using and 2x plus 6 is less than 54. So it is compound inequality. 0 less than or equal to x plus 6, and also 2x plus 6 is less than or equal to 54. Now to solve this type of inequality, I'm going to keep the variable in the middle between the two signs. So I have this 6. I'm going to shift it to the right and to the left. It's like adding minus 6 to all sides of the inequality. I have 0 minus 6, so I can write it as minus 6 less than or equal to 2x less than or equal to 54 minus 6. Then I have minus 6 less than or equal to 2x less than or equal to 54 minus 6 is 48. Now divide by the coefficient, divide by 2 everywhere. So I will have minus 6 divided by 2. Again, we divided by positive number. It is plus 2. We divided by positive number. No need to change the sign of the inequalities. So minus 6 divided by 2 will give me minus 3. Less than. Again, we're keeping the signs are as they are. No need to change because we divided by positive number, not negative. So minus 3 less than or equal to x less than or equal 48 divided by 2 is 24. So this is the solution. You can say, using the set builder notation, will be x where minus 3 less than x less than or equal to 24, and the graph for this one, minus 3 and 24. Closed circles, and the solution will be this area between minus 3 and 24, or I can write it in interval notation to be closed minus 3 and 24. So it is a closed interval because I have equality there, less than or equal. So it is between minus 3 and 24. Let's take another example. Now this type, I'm using OR. If it is OR, we are not looking for the common solution, but we add the solution of the first inequality and the second inequality. Combine them together. So I have, for the first inequality, the first inequality, this two, I will move it to the other side. I will have x less than minus 1 minus 2. And this is the second one, x plus 3 greater than 2. Now the first one will give me x less than minus 3. So I'm going to graph this one. I have x less than minus 3. So minus 3. Open. Less than means go to the left. This is the solution of the first inequality. I can write it as interval notation minus infinity to minus 3. Open. This is the solution of the first inequality. Now the second one, x plus 3, move this 3 to the other side. I will have x greater than or equal to 2 minus 3. Then x will be greater than or equal to minus 1. This is minus 3, minus 2, minus 1. Minus 1, it is a closed interval. And greater than means go to the right. So the solution set of the first of the second inequality, it is closed from this side minus 1 to infinity, open. But since we have OR, then we have to make it union. So the solution set of this inequality, of this compound inequality, using interval notation will be minus infinity to minus 3 union minus 1 to infinity. And using the set builder notation, I will say it is x where x less than minus 3 or x greater than minus 1. So this is the solution set using the set builder notation. Let's have another example. I have 2x minus 7 less than or equal to 15, or 3x minus 1 less than or equal to 5. Solving the first inequality, it is 2x less than, move this to the other side, it will be 15 plus 7. So it is 2x less than or equal to 22 divided by the coefficient. I will have x less than or equal to 11. The second one, let me graph it first. I will have it is a closed circle. Less than means to the left. So it is minus infinity to 11 closed. This is the solution of the first inequality. For the second one, I have 3x minus 1 less than 15. Move this to the other side, it will be 3x less than 15 plus 1. So it is 3x less than or equal to 16, and x will be less than or equal to 16 divided by 3. So 16 over 3, it is about 5 and 1/3. This is equal to 5, 1 over 3, which will be, this is 11, so it will be somewhere. This will be 16 over 3. So x is less than or equal to, closed, again to the left. So both of them to the left. Now the solution of the second one is minus infinity to 16/3 closed. But since we have or, so this must be union. Union means adding this part to this one. So we can write the solution set of this inequality to be x, where x is less than 11. Because we have or, so we combine this with this. If it is union, so it will be including everything in the second inequality and the first inequality. So it is x less than or equal to 11 because it is union. Or in the interval notation, I can write it as minus infinity to 11 closed. So if we have or, we combine the two solutions together using union of the two solutions. Minus infinity to 11 union minus infinity to 16/3. That will give me this one, minus infinity to 11. So this is how to solve compound inequalities. Finding the solution set of the first inequality, find the solution set of the second inequality. If we have and, find the common solution using intersection. If we have or connector, use union and add the two solutions together.